Alright kiddos, welcome back. So your performance task before spring break. Let's talk about it. First thing, labeling the diagram here. They tell you that one radius is 3, so this radius from A to B should be 3. They tell you that the centers are 14 centimeters apart, so this piece right here is 14, and they tell you that the other radius is 5. But what you should notice is that they form a rectangle right here. So this piece is 3, and if the whole thing has to be 5, then that means that this part is 2. Right off the bat, some of you got mixed up with maybe saying 2.5 here and 2.5 here as well. It's not right in the middle. You had to recognize that this is a rectangle. So this 3, because they're all right angles, it's the same with that 3 right there. So that was the first part. I'm going to skip the vocabulary because I think you know how to do that. And move right on to finding the distance of AD. So this piece in blue, which we also find out later is the same distance as F to E down here. These are the same length. And to get there, we had to do one step prior to getting to that point. And where it comes from is this angle right here, which is 81.8 degrees. They give that to you on number 5. And then what I told you on Thursday, the last day we took this, is that if you have a straight line and one side of your straight line has a 90-degree angle, then the other side has to be 90 degrees as well. So we have a right triangle with this dotted line, this 14 length, and the 2. So if we wanted to solve for this dotted line, which will be the same as AD and FE, it's just the Pythagorean theorem. So I'm going to do that off to the side to keep it a little cleaner. So we have triangle, whoa, bad triangle, right angle. 81.8 is not a big factor right now, but we can use this in just a second. 14 is on the bottom, 2 on the side, and we're looking for this. So 14 would be my hypotenuse since it's across from the right angle. 2 could be either A or B. So 2 squared plus B squared equals 14 squared. So 14 squared is 196. 196 minus 4 gives me 192. And the square root of 192 equals 13.8. So this length right here is 13.8, which means that AD is 13.8 and FE is 13.8. I drew those on the diagram, it didn't show you. So there you go. So we have piece number 1, we have piece number 2 of our belt. Let that sink in for just a sec. Another question that they asked is, how many degrees is this little angle over here next to B? And we can use the same triangle right here. If they tell us that this is 81.8, that this one is 90, we know that there's 180 degrees in every triangle. So if we subtract 90 from 180 and then subtract 81.8, we get an answer of 8.2 degrees in that small little corner right there. And that was question that was question number 6. Question number 6. Okay, here's where you had to make just a judgment call, and it was kind of checking to see if you can make a leap forward here, and this is what separated the 1s and 2s from the A's and B's. So anytime I have something going from the center to the top, center to the top, center to the top, what might be happening down here on the other half of the circle? What do you think? Well, it should come to mind that if whatever's on one half of the circle it should be happening on the other half as well, and that is exactly what happens. Where I have a rectangle forming here, a triangle just above it, and so this helps us a ton for problems 8 and 9, because now since I know that this angle is 81.8, I know that the angle on the other side of that is 81.8. And if I know that this angle is 8.2, then I know on the other side of that that's 8.2, and that's a big help. So the question asks on number 8 to find this arc, GHE, and I'll label that orange. We're trying to find this orange part along the outside over here. To find that, we need to know the central angle. How many degrees is my theta in here? And if the whole circle is 360, and I've used 81.8 twice, I just do 360 minus 81.8 and subtract 81.8 again, and I find out that this is 196.4, and whatever the central angle is, you now can plug that into your arc length for theta. So you have 196.4 over 360 equals x over 2 times pi times my radius of 5. Once you solve that, you have 10 times 3.14 times 196.4 divided by 360, and you get this arc length over here is 17.1. Say 17.13, and you use this same idea on the other side of the circle as well, where I have 90. We're trying to find this length right here, where I have a 90-degree angle, a 90-degree angle, and then two little angles of 8.2. So 90 plus 90 is 180, plus 8.2 plus 8.2 gives me this angle of 196.4, but I want the other one. So I do 360 minus 196.4. So this angle over here is 163.6, and I plug that into my same formula, 163.6 over 360 equals x over 2 pi. Now my radius is 3 this time, so 2 pi 3. So 6, 2 times 3 is 6, 6 times 3.14 times 163.6 divided by 360 gives me an arc length of 8.56. If I do that, if you were able to get those parts, you could just add up the 4 pieces, and that would tell you the length of the entire belt. Hopefully you did okay. I'm going to give you an opportunity to make up some points today with your substitute. Mrs. K is being taken care of at the hospital, so I am there with her now. So miss you guys. Hope you had an amazing spring break. And if you have any questions, please feel free to send me a message via Facebook, Twitter, Instagram, whatever you need to do. I am here for you. I love you guys. See you later.